We are almost done with our talk about parabolas. We're going to wrap everything up today. So what we've been doing thus far, we've been taking parabolas in the form of this and transforming them into this form right here. Today we're going to talk about a little bit of just the general geometry of parabolas. Not like there's an actual section in the book about there's like a formal definition and there's certain geometric properties. I'm not too concerned about that kind of stuff. We're just going to make an observation that if you haven't seen it, if you haven't noticed this already with all of the problems you've done, when you see it, you're going to go, oh man, how did that slip by me? This is something that you've seen already 100 times, and we're going to make use of that. But ultimately, what we're doing, what your homework is going to be about is, so we've spent our time going in this direction. We are going to now go back into that direction. We'll get into that in a minute, but that's going to wrap up our talk about parabolas. So we'll get into that in a second. Before we do that, we're gonna go completely somewhere else and talk about something that seems completely unrelated. And so let's do it. Let's say I have two numbers, and let's start simple. Let's go 2 and 6, and we're gonna imagine these on the number line. There's the number 2, it lives 2 units away from the origin. And then there's 6, who lives 6 units away from the origin. What number is right in the middle of those two? Smack in the middle.
4.
I think so. I think it's 4. Let's see. Let's see if it is 4. The way I think about this is if it's something simple like this, I could say, well, hold on. We're at 2 and we're at 6. Let's just bring it in one at a time. So if I bring 2 in by 1, we're here at 3. And if I bring 6 in by 1, we're at 5. If I bring him in one more, I'm at 4. And if I bring him in, oh, we're at the same place. Another way of saying that is that the distance from 4 to 6 is, well, it's 2, and the distance from 2 to 4 is also 2. It's the same distance from each of these points, right? We could say that 4, or the midpoint, is equidistant from the other 2 points, right? So, okay, that's cool. But the way I did that doesn't really help with calculations, especially if we have some crazy stuff like, what's the midpoint between pi and 7? That's going to get ugly, right? So let's think about what I did is I walked it in one at a time, and I don't think that's a very good way of doing it. If we're trying to find half the distance, that seems like a much better way of doing it. If we could say, so first off, what is the distance between 2 and 6?
2? Oh, wait, no. Wait, what?
Yeah, what's the distance between 2 and 6?
4.
It's 4, right? So this is the picture that's going on in my brain is like, okay, I'm thinking about this now as a distance between 2 numbers. And if I took a ruler and I measured and put the 0 right here, this would extend 4 units this way. We'd say, okay, that's 4. But how can we calculate that more generally? What can we do with 6 and 2 to find that distance? Subtract, right? You take the bigger number, the number on the right. Doesn't matter if they're both negative or if one's negative, one's positive. You take the bigger one, right? In this case, it's 6. And you subtract off the smaller number, right? Okay. What I'm trying to do here is I'm trying to develop a method or like an algorithm for finding a midpoint. That's because that's something we want to do.
I remember this.
But let's reason this out, right? We want to find a midpoint here. And what I'm going to do is I'm going to start by saying, well, if I know the distance and I know that the midpoint is halfway between there, I could say, well, hold on, if this distance is 4, what's half that distance?
2.
2, right? And so, yes, I buy that. Okay, so half of that distance right there is 2. And how did we get that distance? Well, we took our original distance, which was 4, and we divided it by 2. Even more generally, what did we do? We took our 2 points, the difference between those 2 points, 6 minus 2, and we divided that by 2 to get half of the distance between the points. Then to arrive at the midpoint, all we need to do is take the original point and add that distance. In other words, if I'm here at 2 and I add this distance right here, I should end up at the midpoint, which is 4. And what's more is because that's half the distance, is that we should have 2 units on the left of that and 2 units on the right of that, which indeed we do, like we saw that originally. So, okay, let's do this one more time. Well, we're going to do this a bunch of more times, but first, let's just think about it this way. Let's use some other numbers and just go through the exact same reasoning. The numbers we're going to use, but first off, before we go through this reasoning, let's see if we can just guess it. I want to know what's the midpoint between, how about 1 and 5? What's halfway between 1 and 5? Let's just try to think about it.
2.5.
Is it 3.5?
Wait, no, it's. Wait.
Just walk it in. Walk 1 in and walk 5 back. And then do it again. Bring 1 over 1 should bring us to 2.
Yeah.
Bring 5 in, that should bring us to 4. Bring 1 over 1 more, it should bring us to 3. Bring 4 over 1 more, it should be 3. That's my guess. I'm guessing it's 3. And it happens to be also, just like my last example, 2 on either side. But let's see. Let's see if we can do this methodically, right? We want to see if our method of doing this, the way we did it before, is still going to work to get us to that middle point. So what was the first thing? I had to find the whole distance, and how do I calculate that whole distance? I couldn't hear you if you said something. How do we find the distance between 1 and 5?
Anything.
Oh, okay.
I was a little bit confused when you did it last time. Is that a multiplication sign?
No. This is an equal sign.
Oh, I'm sorry. I can't see.
Okay, so let's just start fresh, like we haven't done this before. What's the distance between 1 and 5?
5.
Sure about that?
No.
If you took a ruler and put it right here, and your 0 was there, and you go over to 1 right here, and then you have a 2 right here, you'd have a 3 right here and a 4 right there. The distance between 2 points, you told me before, is you take one of them minus the other, right?
Yeah.
So how do I just said it, how do I calculate the distance between 1 and 5?
You subtract 1 away from 5.
There you go, 5 minus 1. And yeah, 1 is tricky because you think, well, it's 5 units, right? No, it's not, right? It's the distance between the two. The distance from 0 to 5 would be 5 units, right? Because if you're here at 0 and you go over 1, then you go over 2, then you go over 3, then you go over 4, then you go over 5. Yes, now you've gone a total of 5 units. But from 5 down to 1, you're only going, you go from 1 to 2, and that's 1, 2 to 3, and that's 2, 3 to 4, and that's 4, 4 to 5, and that is a total of 4. So in general, the distance between two numbers on a line is the bigger number minus the smaller number. And so we have 4. And then what do we do to find half of that distance?
Divided by 2.
We divide it by 2, which gives us 2. And we got that by, we took 5 minus 1, we divided by 2. And so now what we're doing to find the actual midpoint is we go to the left-hand point, which in this case happens to be 1. And then we add this distance right here, that distance of 2, which gives us our actual midpoint 3. And let's just double check something, right? It should be the case that I have 2 units on the left-hand side. And that is the case. The distance between 1 and 3 is 2 units. If I'm at 1, I go over 1 and I end up at 2. I go over 1 more, I end up at 3. If I'm at 3, I go over 1, I end up at 4. I go over 1 more, I end up at 5. And so this is indeed 2 units away. So it's 2 units on both sides, right? It's the same distance on both sides of it. And that gets me to the midpoint. I'm going to be really explicit here. In fact, what I'm going to do is say this 2 right here was obtained this way. I'm going to say you start at the left-hand point, and then you add on half of the distance. So in other words, you take the distance, divide it by 2. Just because we're about to do this in general, and I want what I'm about to do, or what I've done here with actual numbers, I want this to match up really well with what we're going to do in the general case when we take any 2 numbers. So are you following me thus far?
I think so.
Okay. Basically, all we're doing, we're just thinking, in fact, I'm thinking in terms of distances. If I have 2 numbers, I can find the distance between them by just taking the big one minus the small one. And then if I need half that distance, I just half it by dividing by 2. And then to get to the middle point, I start at the left-hand side, add half of that distance, and I should end up smack dab in the middle of those 2 numbers. So what I want to do then is say, well, how can we do this for any 2 numbers? Let's say I want to do this for a number A and a number B right there. We're going to assume B is the bigger number. We're going to write it on the right-hand side so that we remember that, yeah, okay, the B is the bigger number. And so then what is the distance between A and B? How would I calculate that?
Hold on, I'm writing this down. Would be B minus A.
Exactly, right? Assuming that B is the bigger number, which is how we've drawn it, we just take the big number minus the small number. So this distance right there is simply B minus A. Now, if we're trying to end up in the middle of those guys, it would be nice to know what half of that distance is. So how do I write half of that distance? What do I need to do to that number right there?
Divide it by 2.
Divide it by 2. Whatever that number is, B minus A, whatever it happens to be, I take that number, divide it by 2, and that should be that distance. So for instance, when we were trying to find the distance between 1 and 5, we said you go up to 5 and you subtract 1 and you get a total of 4. That guy right there. And then we said, well, half of that distance is, well, it's 2 because 2 is half of 4. But what we did is we said, well, you take the distance and divide it by 2. So in symbols, we're doing the same thing. You take whatever that distance is over 2, and that number that you get is half of the distance from there to there. And that's where we want to end up. So last time what I said is if we're at 1, and we move over to the right 2 units, we'll end up at the midpoint. So that's what we're going to do here. We're going to say if you're at A, all we need to do is add on that many units, which is, well, whatever it is. I'm just going to write it as B minus A over 2. And that right there should be my midpoint. We could even call this a midpoint formula if you want. Problem is we have like a number and we have a fraction, right? We have A all by itself and we have something over 2. It would be nice if we could write this all with one common denominator. What can we do to get a common denominator here? If you're not sure, think about what you would do if you had, oh, I don't know, 5 plus a half. And you wanted to write 5 with the same denominator as the 1/2.
Sorry. All right. A over, no, wait, A. Yeah, A over 2, right? No.
Well, A over 2 would be half of A. It's going to be over 2. It's going to be something over 2, but we want it to still equal A. So what do we have to do? How would you do this? What would you do with 5?
You would multiply it by 2.
Yeah, exactly. We're going to multiply the top and the bottom by 2. That's how I think about it, right? Like when you're bringing in fractions into play, we say, well, if we multiply the top and the bottom by 2, we haven't actually changed the fraction. And so we would have 5 times 2 over 2 is the same thing as 5. And so that's how we would do that. It would be 10 over 2, yeah. But in this case, how would we write that bad boy?
2A over 2.
2A over 2. There you go. That is exactly what that is. And I can just see, yes, 2A, you have 2 A's, and you divide it by 2, you would just have 1 A, yeah. And so, okay, we have a common denominator. Let's put them all over that same denominator and see if we could simplify. And what does that work out to?
Sorry, I'm sorry. Okay. B over 2, I think. Yeah. No, wait.
What is, you might have said the right thing. You kind of cut out. I didn't hear you.
Oh, I'm sorry. I said B over 2. No, A plus B over 2. Yeah.
There we go. Yeah, because you have 2 A's. You take off 1 A. You're left with 1 A left over. So yes, this is A plus B over 2. So that would be a nifty way of writing this. And let's just see if it works. Let's kind of, and do you notice what this is? I took a certain number of numbers, added them together, and then divided by the number of numbers that I had. What do we call that?
Um,
I'm going to say it and you're going to go, yeah, of course. We call this an average. You take the average. The average of two things is what you get when you add the two things together and divide by 2. The average of 3 things is what you get when you add those 3 things together and divide by 3. The average of n things is what you get when you add all of the n things together and divide by n, the number of things that you have. This just happens to be the case that this is the average of those two numbers. And what do you know? The average should end up smack in the middle of those two things. So like if I told you you got a 90% on your last quiz, and oh, by the way, you got 105 on your last quiz, great job. I didn't say that when we first started talking. Excellent. You killed it. Perfect. Great job. So we could do that. Let's say I told you that you got 105 on your last quiz and 103 on the quiz before that. You'd say, and then if I were to say, well, if you wanted to know your average of those two quizzes, you would just add them together and divide by 2. Or you would find the midpoint between those two numbers. It's the same thing. Just when we think about midpoint, it's more geometric, right? We're thinking about distances and stuff like that. Let's just verify that this, I guess we'll call it a formula. I hate to talk about formulas, but we'll think about this as a midpoint formula. But let's just remember that the midpoint is an average it's the average place between two things, which happens to be smack in the middle. Let's just verify that this works for that right there. So we have the number 1 and the number 5. What's the average of those two numbers? Well, I take 1 plus 5, divide it by 2, right? That's all this says to do right there. 1 plus 5 is 6. Divided by 2, 6 divided by 2 is indeed 3. Look at that. It works. We end up getting the same thing. 3, another way of saying that is 3 is the average of 1 and 5. So the midpoint is the average. It means the same thing. When you're talking about 2 points, the average of those numbers is smack in the middle of those numbers. Doesn't matter if they're both positive, if they're both negative, if they're positive and negative. In fact, let's do one like that. Let's go through the same reasoning that we did before. I'm about to erase what's over here on the left-hand side. Are you good with the left-hand side?
Yeah.
Okay. So I want to do this the way that we did it before, where we walk through actually just trying to think of distances first. And then we're going to do it the long drawn out way where we find the distance, half the distance, add it to the original thing. And then finally, we're just going to take the average of those two numbers and see if everything works out. So what did I want to use? I wanted to use, that is what I want. Or was it? One second, I'm sorry. There was one in particular I wanted to use. Yes, okay, so let's use these two numbers, -3 and +1. Let's just, let's try to walk that in and see what should the middle point be. If we bring 3 in by 1 and bring 1 down by 1, and then bring them again, what should we end up in the middle here?
-3, maybe 1.
What'd you say?
I was repeating the.
Oh, okay.
just
You were
-3,
saying
1. So,
between -3 and +1.
it's -1.
Should be -1. And what do you know? It happens to be the same distance between the two. You go down by 1, you go down from 1 by 1, you end up at 0. Go down 1 more, you're at -1. If you're at -3, you go up to -2. You go up one more to -1, and those distances are both 2 and 2. Okay, so let's do this systematically now, the way we reasoned through before. What is the distance between 1 and -3?
4.
Yes, and how did you find it? Or how could you find it if you just looked at it and said that's 4? How could you find it?
1 minus a -3 is just 1 plus 3.
There you go, right? Yep, 1 minus the bigger one minus the smaller one. 1 minus -3 is the same thing as 1 plus 3, which gives you 4, okay? What's half of that?
2.
It's 2. And we got that by taking the original thing we had, which was 1 minus -3, and we divided it by 2. Finally, we're going to take the left-hand point, which is -3, and we're going to add on that distance of 2, and -3 plus 2 brings us to what number?
-1.
-1. Now let's do it the other way, because all this is this formula in disguise. Let's just take the average of those two numbers. Two numbers that I'm going to take the average of. It's going to look like that. Plug in the one on the left, we get -3 plus 1. Okay, -3 plus 1 is what?
-2.
-2 divided by 2 is what?
1. -1. No, sorry, -1.
You better say -1. Yes. And so lo and behold, yes, the midpoint is simply the average of those two numbers. And what I really want to beat home here is that it's not so like you're not going to use this, by the way, like this is not part of your homework or anything like that. It's that, yes, this is, if you were to look up midpoint formula, this is what you'd find, right, in your book. And I just want us to notice, like, yeah, that's an average of two numbers and it ends up right in the middle. And I believe that now because I've gone through this reasoning, right? But the important thing to notice is that when you take a midpoint between two numbers, then the distances from here to here are exactly the same. That's how we've defined this in the first place, right? Like if you're at a point and you go 2 units to the left and map it out, you come back and you go 2 units to the right and you map it out. Guess what? That guy is smack in the center. It's the average of those 2 points that you have. I want to wrap this up with looking at it this way. So we have that the average of two numbers is the midpoint. And we got that by saying, well, let's look at the distances from here to there. And we found that, okay, you have this nifty little formula for that. That's cool. Let's go in this the other way. And I want to do this. So am I good to erase this stuff here on the left side?
Yeah.
But I said that this, and the important thing that we want to take away right now is that if you're at a midpoint, so instead of trying to find a midpoint, if you're at a midpoint, and that midpoint could be anything. In fact, let's just call it X. So you're at this point, X. And if you go to the right by any distance, I don't care how big or small that distance is. And in fact, it could be anything. Let's say that it's, I don't know, let's call it Y for that matter. We'll just say that that distance from there to there is y units, then this point right here would be what? How would I find what that is? Like, for instance, if I told you you're at 3, go right 2 units, what would you do to find where you are? If I said you're at 3, go to the right 2 units, you would end up where?
Five.
You end up at 5. How could you calculate that? What would you do?
3 plus 2.
3 plus 2. So if you're at x and you go to the right y units, you're where?
X plus y.
X plus y. Okay, there we go. Right? That's where that is. That is the point. You go, you're at x and you go plus y. So how do we get y units in that direction? We want to go y units that way. It brings us to another point. What would that point be?
X minus y.
X minus y. There you go. That's where you are. Okay. So there's no, it sounds weird when I'm asking it. You're like, is that really what he's asking for? It's x plus y, x minus y. Yeah, that's, but I just want to make sure that we're on the same page. We're at some point, and I tell you to go y units this way, and you end up at what we're going to call x plus y. And then you go x minus y, and I claim that that is the midpoint right there. Let's check it, right? We know that the midpoint is the average of these two numbers. In other words, a plus b over 2, right? Given a 1 on the left, a, 1 on the right, b. All I need to do is add them together, divide them by 2, and we will end up at the midpoint. Let's check that that works. So I'm going to plug in for a, the one on the left, which is just x minus y. And I'm going to add the one on the right, x plus y, and I'm going to take that and divide it by 2. I believe that this top simplifies. What can help? No, that was right. How can we simplify this numerator right there?
You just have 2x over 2, right?
Because the y's cancel, right? The plus y and the minus y go away. You have 2 x's over 2, which does indeed equal what?
X.
Just x, just like we expect. Okay, so there's nothing new here going on. I just wanted to solidify in our minds that halfway between two numbers is the average of the two numbers. And so similarly, my intuition tells me that if I'm at a point in the middle and I go any distance to the right, I end up somewhere else. But if I go that exact same distance to the left, then I should be at the exact middle between them, because I've gone, like, that's how we define the midpoint, right? That's how we started all this off. We said the distance, half of the total distance is there, blah, 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 blah. Okay. Is all this making sense?
I think so.
Do you believe it? Do you believe what I've said thus far?
Yes.
That's the whole point of that. That's why I went, because I really wanted to, like, you know, we could have said like, well, you knew this in algebra 1 or whatever, and so we'll just plug along. I really wanted to beat this home or drive this point home because, yeah, just you'll see in just a second. Now, okay, let's see something here. I'm gonna get rid of this. Let's think about this now. Okay. Let's do something else now. You've seen this before. I'm going to give you that, and I'm going to give you a couple minutes, and you tell me, you solve for x, and you tell me what x values we have. So enjoy. I will also do it And I'm gonna trust that you're not looking at the screen and copying what I'm doing. It doesn't matter. Okay.
Wait, excuse me, one's x plus. Okay.
Okay. Let me know when you got it.
Got it.
What did you get?
That. Minus 1 plus 1.
You notice something that is in every single one of these that you've done, and you've done a lot of them now. They always end up exactly like this. In other words, the roots are, you go to some number, in this case it's -1. It says that the roots can be found by going to this number -1, going to the right by 2 units, which brings you up to, I guess, +1, and then going to the left by 2 units. That's what plus and minus means, right? Like in one case, you're going to the right. In the other case, you're going to the left. And you end up, the interesting thing is that the way this is written, every single time that it's written this way, this number that shows up right here is always smack in the middle of your roots. Every single time, right? That's what we just proved right here, that anytime you have 2 numbers that are in the form x plus or minus the same distance, then that first number, right? This number right here is always smack in the middle of these 2 things. Oh, buddy, you have your water. It's right here. Okay, you can have the bubble water. Bubble water. There you go. He loves the bubble water. So now we got this right here. Now, forget that I said all of that stuff right there. Forget it for a second. And let's think about what this thing is in terms of the graph x squared, and we're shifting it and stretching it and shifting it. This, where does the vertex end up with this guy? So first off, this is x squared, and it's shift. First, we shift in what direction and how many units?
Sorry, I'm still coughing.
Okay, no problem.
I realized I should probably be writing most of this down. So okay, great.
Okay.
Okay, let's see, 2x. Okay, I'm sorry, may you ask the question again?
Yeah, so we're going to think about this as the regular function x squared, but it's been shifted and stretched and shifted again. And what's the first shift that we do? What direction and how many units?
Okay, the first shift we do is +1, which is to the left. 1 unit.
It's to the left, how many units?
1.
And so we end up we're basically taking that vertex of that parabola and shifting it over to -1. Okay, then what happens to it?
Then it gets, pretty sure it gets not reflected. I meant, okay. Stretch vertically.
Yeah. So we started off by saying, okay, x plus 1 squared. So we just shifted it over to the left by 1 unit. So in other words, it ended up at -1. Then with the multiply the outputs by 2, that's going to stretch it up like that. And that new guy that we have is 2x plus 1 squared. Finally, now what happens to that guy?
It gets moved down 8 units.
It gets moved down 8 units. And let's just look at this real quick. Let's imagine this parabola right here, the long skinny one that I've drawn, right? The 2x plus 1 squared right there. If we drag it straight down, that vertex is still there at -1, right? And in fact, in the end, when I'm going to ask you, okay, where does that vertex end up? The x value is -1, isn't it? And yeah, and all we've done is we've taken this thing and we pulled it down. And so it's still symmetric, right? And finally, when we go to do all this, like you did in the homework and the quizzes and stuff like that, you go and you find the zeros, and we've already done that. So we know that one of them's over here at +1. The other one is over here at -3. And look at that bad boy right there. The plus and the -2 are the same distance from there to there. You go +2, you end up at +1. You go -2, you end up at -3, but we're splitting the middle right here, right? That middle has not changed. And in fact, it's entirely determined by that number right there. That number is exactly how you find the vertex of a parabola. In fact, we don't need to go through all of the stretching and stuff like that to find out what a vertex is. For instance, get rid of this stuff and say, let's suppose that I had something crazy like -7/3 x minus a half squared plus, oh, I don't know, how about pi/2, something crazy like that. And I ask you, where's the vertex of that guy? Where's the vertex? Let's think about what we did, right? The vertex is, you just think about the 2 shifts that we have, right? One of them moves it to the right and the left, the other one moves it up and down. So ultimately, where does the vertex end up with this guy right there?
Okay, there we go.
All right, sorry, I was trying to distract Pete and he caught me. So.
Three. Okay. So boy. Are you wanting me to graph this?
No, just all I asked is where does the vertex end up?
Well, at plus 1/2, so positive 1/2.
Plus 1/2, and then where?
Pi over 2.
Up at pi over 2. And now here's another thing. We don't need to necessarily go into this, but I noticed that that is going to flip it down, right? Because it's a negative number out in front of it. And so one thing that I know about that is that this distance from here to this 0 is going to be exactly the same as the distance from here to that 0. And if I wanted to, I could go through and solve this like that. But in case you haven't noticed yet, every single one of these problems, and I'm going to go ahead and get rid of this. Like we take this and bring everything over to one side, and we end up with something like this. In this case, it's minus pi over 2, but that doesn't really matter. We're going to take this and divide it through so that we end up with something that looks like this. And whatever number that is, who cares? That's not really the point right now. The point is that I don't care what numbers this thing looks like. I don't care how bad it is. If that's a pi over 2, if that's like e to the 5th over 3, it doesn't matter. You'll be able to get them all by themselves. And you'll notice that then when you take the square root, we said you always get a positive and a negative. And so what's left over here is the square root plus or minus the square root of something. Sometimes it comes out to be a nice nifty number like this. Sometimes it's a square root of something. Sometimes it's imaginary. But the thing is that this thing always, always, always comes over like this. And then he gets plus or minus some distance. And so this bad boy is always halfway between the roots, and it's also exactly where the vertex is. In fact, we could say like this is the x value of the vertex, right? Like that's what I asked you at the very beginning here was like, where does this vertex end up? And you said, well, it's a shift to the right by 1/2 unit, so it ends up at 1/2. And then it's a shift up by that much, so it ends up right there. And so the x value of the vertex is entirely contained right here. The y value is also right there, right? And there you don't have to do any kind of tricks with your brain. You just like, well, if it's a plus pi over 2, it ends up at plus pi over 2. Similarly, now here's where we're, so does all of this make sense, everything that I'm saying thus far?
Yeah.
Okay, so that's where we've been. Now let's see how we're going to get back, because remember at the beginning what I was saying is we've been taking ax squared plus bx plus c and turning it into our nifty little form. Now we want to go backwards, but what I want to do is something like this. Let's say that I had a parabola and I knew that its vertex ended up here at 2 and positive 1. And okay, if I know that it's a parabola, then I know that it has this form, ax plus or minus h squared plus or minus k. And we could say, well, if he's been shifted over to the right by 2 units, then what does this have to be? This has to be x what squared plus or minus what? So first off, let's just do the horizontal shift. What has to go in here for a vertex to end up at the point 2, 1?
Minus True.
There you go. That easy, right? And it has to be. That's what that means. Like, this is what we've been doing. We've been coming at it from the other direction, but every single time that vertex, we knew where it was by this number right there. That's how we've done all of this. So then what is this going to be? Plus or minus what for the upward shift?
+1.
+1. There you go. The only thing that remains is that number A. What your homework's going to be like is I'm going to tell you where the vertex is. That gives you this right here. That lets you know, hey, my function looks like this. And then if I give you any other point on that parabola, and I'm just going to make one up right now. Let's say that we're at the point 3, -1. And I'm telling you that that point is on my parabola. So, well, one thing I know, if that's the vertex, then that has to be the highest point right there. This has to come down like this. And here's the question, like, we don't know this right now, and actually graphing this part out is not really going to be necessary. We don't know whether it's really skinny or really fat. I mean, we could, if we wanted to, we could argue by symmetry and say, well, by symmetry, if it comes over this much, it's got to go over the same. And so it needs to look more like that. But that's not really the point. We have enough information to solve for A, because I know that if I plug in a 3, right, this tells me that when my x equals 3, then my y, or my output, is equal to -1. In other words, plug in a 3 into f and you get out a -1. So f of +3 is equal to, I'm going to give myself some space and say -1, like that. And so, okay, and the whole idea is we just need to find A right there. A is the number that we're looking for. And so I'm going to do this. Let's say, all right, plugged in a 3. And so now we have, instead of x -2, we're going to have 3 -2 right there. 3 -2 is equal to 1 squared. That's 1. So you saw what I did there, right? Is I'm just saying, when I plug in a 3, I get out a 1. And that's why I wrote that. I'm sorry. Plug in a 3, you get out a -1. And so when I plug in a 3, that's what it looks like. And it tells me the output, that when I'm done calculating that, I get out a -1. And so that means that this number, when I'm done, should equal to -1. And that's what I'm doing. A times 1 squared is just A, plus 1 equals -1. Finally, A should equal -2 right there. So now with 2 points, I was able to find the equation of this parabola. And in particular, I'm going to go ahead and write it down. F is equal to, the A is now a -2. So -2 x -2 quantity squared plus 1 right there. That's my parabola. What I'm going to ask you to do in your homework is then rewrite this in standard form. Right, the ax squared plus bx plus c. So are you following me thus far? You saw how I got all this. Any questions?
No questions.
So, and the key here is that I'm treating this thing as a function. I have enough information. So I have a function with 3 unknowns. It's like, I know that it's a parabola, so I know that it looks like this. Every single parabola can be written in this form. You should believe that by now, right? We've done a lot of that where we've said, you give me any parabola and I can rewrite it like this. Knowing where the vertex is gives me these numbers right here, okay? And then And so another thing, if it were over here, if it were -2, we'd have to have a +2 in here. If the vertex were at, say, -7, I'd have to have a -7 right there. But the vertex tells me these two numbers, so that much is gone. The only thing that's left is to find, well, what value of a then do I need for my parabola? The cool thing is that I'm using the fact that this is a function that if I plug in a 3, I get out a 1. And so I'm saying f of 3, the output is equal to, -1. And that's all I've done here. I just said, well, okay, well, let's just plug in a 3 and see what happens. Oh, the a can isolate now. We're done with all the other variables. We get a by itself, and that finally gives me this function right here, which I want written, or I'm going to ask to be written in standard form. And so squaring this guy out gives me x minus 2 squared is x squared. Minus 2x is a -4x. Minus 2 squared is +4. Distributing the -2 gives me a -2x squared plus 8x -8 plus 1. Finally, I'm going to write just above this as -2x squared plus 8x -7. Sorry, that looks so ugly, but I really want to save some room on the board, and I want to keep these guys up there because there's more to this story. Do you have all of this?
Just 1 second.
Okay, that's fine.
Okay.
Okay, so one thing that I say in the homework is you do not need to graph this in order to do this type of problem, but it certainly helps. At least it helps me. Like, and it doesn't have to be like, you'll notice that when I just did a thumbnail sketch, right? I was like, well, if I know my vertex is here and my point is down here, then it does something like this. And this just kind of helps me with the overall picture of the things I'm doing. I'm plugging in a 3, I'm getting out a -1. You know, whereas if I didn't have this picture, at least for me, I would feel like I was just following some algorithm, and it would be like, oh, what do I do now? Well, now you plug in a 3 and you make that equal to -1. But here it kind of helps me keep all of this keep the bigger picture in mind, and the idea that I'm, given a parabola, and a parabola has certain properties. It looks a certain way. And so, yeah, I'm basically just keeping myself honest by drawing it. It's not necessary, but I highly recommend doing it. Just a thumbnail sketch. Doesn't need to be perfect. It doesn't matter if you draw it all wonky. You're just keeping the big idea here. So, okay, now what are we going to do? So, okay. You do not, this is going to be one of the few times I'm going to say this. You do not need to write out what I'm about to write out because I know you've written it before. Oh. I know you've written it before. But I'm going to do this fast and furious so that we can really buy that this is true. Given ax squared plus bx plus c. We could factor out an a, giving me x squared plus b over ax plus c. Taking half of that term, I'm just completing the square here. I'm going to say half of b over a is b over 2a quantity squared minus b over 2a quantity squared. Finally, plus c. That is a perfect square, which comes out like this. X plus b over 2a quantity squared minus b over 2a squared, all plus c. Yeah, I buy that, right? That's the perfect square right there. That's it written like that. That works, okay? Why don't I go ahead and do this? I'm just going to go ahead and square this bad boy out. That's b squared over 4a squared plus c. Distributing the a back through, and we get a times x plus b over 2a quantity squared. Minus the a comes over and kills one of the a's in the denominator, giving me 4a right there. I distributed the a, so he's gone. There's that right there. Okay, now if we were saying, well, let's just do it this way. If we were trying to, let's say, find the vertex of this bad boy right there, where is the x value of the vertex? In other words, this is a shift. In what direction by how much? First off, we're thinking about the very first shift that you're going to do, because that's the x direction shift. Is it to the right or to the left?
Left.
How many units?
Over 2a.
B over 2a units. Okay, right? That's where the vertex ends up. Another thing to notice is that if you went through and solved this for 0 each time, let's say that we were trying to solve that equation right there, we would say, well, I guess I'll bring all that other stuff over to the right-hand side. And we've seen this before, right? That ends up being b squared over 4a plus c. And then we rewrite c to have a common denominator. And we say, well, okay, if I multiply the top and the bottom by 4a, then I end up with a 4ac. Oh, that should be a minus. That should be a minus. Yep, okay. And so we say, oh, well, that just means a x plus b over 2a quantity squared is the same thing as b squared minus 4ac all over 4a. And then we say, well, wait a second, we're almost done. I just need to get that a out of there. If I divide both sides by a, I end up with x plus b over 2a quantity squared equals b squared minus 4ac all over 4a squared. And then I take a square root of both sides. That gives me a positive and a negative answer. So I get a plus or minus the square root of b squared minus 4ac all over the square root of 4a squared, which is just 2a, right? Something like that. And so we've already done this. And like I said, this is fast and furious. Like I'm just getting to the point here is that I don't care what three numbers you started with. We call this bad boy the quadratic formula. And look at what it tells me right there. It says that the zeros of this parabola, so I'm going to go ahead and get rid of a lot of this stuff. That the zeros of this parabola occur at minus b over 2a plus a certain distance, which happens to be the square root of b squared minus 4ac all over 2a, to end up at minus b over 2a plus the amount. And then the same distance to the left, where you end up at the point minus b over 2a minus that amount, whatever it happens to be, b squared minus 4ac all over a. And you just told me because of the way that we've written this thing, we know that that midpoint right there is where the vertex ends up. In other words, when the x value is minus b over 2a, then you know you are at the vertex. And this agrees with everything that we've been talking about with parabolas. Is that, and we did it earlier, right? When it was x minus 2, you said, oh, that's a shift to the right by 2 units. And indeed, when you go to solve that for, if you were to go to solve this to find the zeros, you would find when you go and take your square root, you would have on the left-hand side, x minus 2 equals plus or minus the square root of something, some distance, plus and minus. And so you would have x equals 2 plus or minus the square root of some stuff. And so what do you know? 2 is that bad boy right there. And you go to the right by some amount, go to the left some amount. That guy is always the x value of the vertex. So what we could have done, and this is what you're going to do in your homework, you're going to be given a vertex and a point, and you're going to have to derive this guy right there. And then from that, you can find the standard form of this. And what we're going to do is verify that this formula does indeed give you the vertex that you're looking for. And this is how it's going to look. You're going to say, well, with this parabola right here, f of x equals minus 2x squared plus 8x minus 7. If we're thinking about this in terms of ax squared plus bx plus c, the a is equal to what?
Minus 2.
And the b is equal to what?
8.
Plus 8. And the c is equal to?
Minus 7.
Minus 7. And the vertex apparently always shows up at when x is equal to minus b over 2a. So let's go ahead and do that. We say that the x for the vertex is equal to minus b over 2a. Minus b would be minus 8 over 2 times a is minus 2. Note how I'm using parentheses. This is your best friend right here. Okay, so that's negative 8 over negative 4. What's negative 8 over negative 4? No, I'm not. I don't know what's going on. It is a positive 2. So negative, negative, positive 2. And lo and behold, that's exactly what we expect here, right? Because this is a shift to the right by 2 units. That should bring my vertex over to positive 2. Then up to 1, right? Or well, over to positive 2, stretched and all that, and then up to 1. And so, but assuming we don't have this, how can we find the value, the output value of that vertex? Well, we know that x is equal to positive 2, and we're just looking for the output value. This is just a function. This is just some parabola. And so if I want to know what the y value is when the x value is 2, I just plug in 2 right there. So let's do it. F of 2, the output value, f of 2 will give me, let's see, minus 2 squared plus 8 times 2 minus 7, just like that. And so simplifying this, we have minus 2 times 2 squared is minus 2 times 4. 8 times 2 is 16, minus 7. So we have minus 8 plus 16 minus 7. Minus 8 plus 16 is plus 8. Minus 7 should be a positive 1. Lo and behold, that is the vertex of the original function. So that's what we're trying to verify here. That these, again, these are the same thing. They're exactly equal. And one of them helps you find the vertex really easily. One of them, it's not so easy, but it's actually not that bad because, well, because of this fact right here, right? We could take any one of these guys, turn it into that, this form, and find that, well, the vertex is dead smack in the middle of the roots. And it has a nice nifty, when you write it this way, it's real easy to see where that vertex is, or what the X value for the vertex is. And so if we then take that and plug it into the function right here, then we can find its output value, right? It find its height, this tells us it's 1. And so that verifies that this tells me the vertex should be at +2, +1, which was what it was given at. And we went through, turned it into standard form and found that, yeah, this also works this way. We're basically saying the same thing in 2 different ways. That's what math is all about, really. And so that's what you're going to be doing in your homework, is this kind of thing, right? I'm going to give you a vertex, and I'm going to give you a point on the parabola. And I have a worked example that's very in depth, or I'm very wordy about it, so that if all of this went by you really fast, you'll have it right there. And of course, I'm going to put this lecture up online. You could watch this again. There's only 5 questions, and it's this type of thing, just over and over again, with 5 different vertices, 5 different points on parabolas. But this is what you're doing just over and over again. I also have you find the roots. And in one case, you find the roots by just doing this thing, which is the easy way. And then you're just going to plug them into this equation to verify that, yes, this quadratic formula does indeed give you the same thing as this, which it should, because that's where it came from. But yeah, that's the idea with that. Any questions? No? So one last thing I wanted to do, and you're probably going to hate me for this, but I just have to this is going to drive me crazy if I don't do this, to tie this all up together. I said that this is the midpoint between these 2 things. And I said that because, well, you have some value, whatever it happens to be. You add some value to it. Okay, then you end up there. You subtract some value from it. Yeah, that's kind of how we defined the midpoint of something at the very beginning. Let's wrap this up by just checking the very first thing we did. We said that that to find the midpoint, you take the average of 2 numbers. And so one of the numbers we are trying to, that we're using, is the -b/2a plus the square root of the stuff. Right? The other one is -b/2a minus that stuff. See? All over 2a. And we want to find the midpoint right here. We could say, well, we know that the midpoint is just the average of those 2 numbers. So we'll just average those 2 numbers and see what we get. The one on the left-hand side was the -b/2a minus the stuff. And I'm not gonna waste my time to fill in the b² - 4ac. You know what it means. I know what it means. It's there. -b/2a plus the stuff. Okay, that's the midpoint. Just by definition, we're just taking the average of these 2 numbers, whatever they happen to be. Cool thing is, kind of like what we saw earlier when we took the average of x minus y and x plus y, those y's canceled out. Well, that's the same thing that's going to happen here, right? Because we have -b/2a. In fact, I'm going to think about that as a number in and of itself, minus the square root of the stuff over 2a, plus -b/2a plus the square root of the stuff over 2a, all over 2. Well, the plus and the minus square roots cancel. The same way that the y's canceled earlier. right? So those guys are gone. What we're left with is minus b over 2a plus minus b over 2a all over 2. In other words, one apple plus one more apple gives me a total of 2 apples over 2. Now apples happen to be minus b over 2, right? And just like we saw earlier, right, when we were doing this with the x's and the y's, you ended up with 2 x's on top divided by 2. Same thing's happening here. Those guys are gone.
Here, stop. Don't do that.
And all we're left with is minus b over 2a. So yes, indeed, that part of this formula, right, that first part, because I like to write it in these 2 separate parts, turns out to be the midpoint between these 2 roots. And that midpoint is always, always the vertex, or the x value of the vertex, which is always equal to minus b over 2a. So why spend so much time talking about this? Well, sometimes it's, if all you're looking for is the vertex, it's way easier to just remember this nifty little fact. And that way, if you're given something, say, like this, you don't have to go through and complete the square and turn it into the form ax minus h squared plus k. You don't need to go through all that. You could just say, wait a second, if all I care about is the vertex, I know that the vertex occurs at minus b over 2a. And so I could say, well, then that should be minus 7 over 2 times 4, or how about minus 7/8? And so I know the x value of the vertex. I'm down here at minus 7/8. And then I could say, okay, well then what's the height value for that? Well, I just plug that guy back in. I just say, okay, well, I could just plug him in. We're not going to do it, but we could, and it wouldn't take too long. We plug it in and we see, okay, it's maybe it's up here at 5 halves or something like that. Well, now we have the vertex, and as we will see when we go to do applications, it's really nice to know where a vertex is, because that's usually the thing you're trying to find, because that represents the highest value of something, where your spaceship before it comes down, or the value of your stocks when they're at their very lowest, or something like that. So I think that's it. That's fast and furious. Any questions?
Not yet.
Okay. Any questions you have at any time, get with me. I will try to be on my phone as much as I can.
Okay.
But I will send you, I already have the homework all written out and stuff like that. And if there's any questions, the example that I work out in the homework should take care of everything.
Okay.